Hello, today we're going to talk about average rate of change. What type of functions are shown in the table below? Explain how you know. So if you look, I always start with the output column and I look what the change in y is. So the change in y here is plus 3, plus 3, plus 3, and the change in x is plus 1, plus 1, plus 1. So the average rate of change here, or when we're talking about the change in y over the change in x, that is also known as slope. Good. And the slope for the first function is 3 over 1, and it has a constant rate of change. So what type of function has a constant rate of change or slope? Linear. In the second table, if I first look at the change in y, I would see from 24 to 48, it goes up by 24, when the x goes up by 1. Now, when I go from 48 to 96, does it still go up by 24? Well, if I add 24 to 48, I would get 72, which is not 96. So therefore, there is not a constant rate of change. Here, I would be adding 40, whatever, I don't know, but not 24. So let's look at a different relationship. Going from 24 to 48 is doubling. Going from 48 to 96, doubling. 96 to 192, also doubling. All the x's are going up by 1. So when we have this common ratio or common factor from one output to the other, this would be a exponential function, our current topic. The exponential function has a common factor or ratio rather than having a constant rate of change. So that's how you would be able to tell the difference between a linear function and an exponential function. So today we're talking about getting your average rate of change. Your average rate of change, I guess we'll discuss right after this. Here they're talking about a mouse population starts with 2,000 mice and grows at a rate of 5% per year. The number of mice after 2 years could be modeled by the equation. So what we're interested in right now is the table for this function. Okay, this function shows that you're starting with 2,000 mice and you're increasing by 5%. Okay, you learned that in algebra, how to write an exponential equation given that information. Here it gives you the equation. What is the average rate of change of the mice between the second year and the 5th year? So I'm going to take that function and make a table, but I'm only interested in second year and 5th year. So how am I going to get the outputs? You could plug in, or using the table, I could put that equation in, 2,000 times 1.05, and I want the exponent to be the variable. Now I'll go to the table of values. I need 2 and 5 in it, so I'll go up to 5. And I could see from my table of values that the output when the input is 2 is 2205, and the output for 5 is 2552.5631 ... Now going back to the calculator, I could find my change in y. My change in y is going to be that 52.5631 number I could use. Yeah, I'll just do that. 2552.5631 minus the 2205. That'll give me my change in y. 347.5630 over my change in x is just the 5 minus 2, and that'll give me 3. And then if I divide those two numbers, 347.56309 minus 3 is 300. No, that doesn't make sense. I didn't want to subtract. I wanted to divide. There we go. That makes a little more sense. 115.854, and it wanted to the nearest whole number, so it'll be the 116. Another way I could have done it in the calculator after getting that function in there, I could have gotten the change in the outputs by doing, let's say, using the f of x keyboard. Just kidding, I can't use the f of x. Using the alphabet keyboard, I'm going to do f and then go to the numbers, and I could put the input in. So I could find f of 5 first or f of 2 first. It wouldn't matter. So let's do f of 5 minus letter f parentheses number 2. And that would have given me the change in y also. Now to get the change in x, I would just have to do 5 minus 2. Now notice, I can't point to the calculator, but if you look on the calculator, do you see it says a equals f of 5 minus f of 2? So now I could use that a for that number and just type in a divided by the change in x we know is 3. If you weren't sure, you could do the 5 minus 2. And then I could give it to you without having to worry about rounding or looking at the table. But you have to first enter in that function so that the f function is defined by the equation. So either way, we get the same answer.